Hi, welcome to a bonus video. This video belongs to the playlist called Introduction to Galapagos, and I'm recording this video to come up with another solution for a comment that I read yesterday. So it's basically our friend is asking if it's possible to use Ladybug tools to calculate the shadows of a period of sunlight. So by this being said, what we can do is we can create this in our uh, exercise file. So what I do now is I go back to here and then pull up my exercise file. This was the exercise file. And now what we are going to do is we'll be using Ladybug tools to calculate this area of the shadows. So what I'll do is I'll be pulling out an EPV map and I'll be pulling out a download weather data because we are going to locate this geometry on a position in the earth and create sort of a sun path, and by using that sun path we'll be calculating the shaded areas. So we open up our EPV map. We are going to select, let's say, Boston, and grab this is all up to you. Creating a panel, pulling the panel in, and copy pasting my location to this panel, and pulling out the EPV file. And then I can import this EPV file to create my sun path, right? So if I create a sun path here, it will be asking me the location and the period, analysis period. For the analysis period, what we can put here is basically month 6, because it's gonna be summer. We need more shaded areas in summer. The first day of it, start hour is the 9, let's say, or 8 a.m. and month 8, meaning August 31st day, and the hour is going to be 20. And let's put the OS to the OS, and we'll see some things over here. Center point can be somewhere else. Let's put the center point as this one, and let's put 1 point here and scale it with 3. And now we see our sun path over here. The next thing that I'll be doing is I'll be calculating the sun hours, direct sun hours, and these are going to be my vectors. My geometry is going to be this guy here, but let's draw a small surface first just to test what we are doing, okay? And put that surface as my geometry, set one surface, okay? And this is going to be my geometry. Grid size, let's say 10 meters. And for the context, we'll be using this guy as my meshes because these are my meshes. Oops, not this one. This is from Millipede and not from another plugin. So these are my meshes, and I can wire display and hidden this, and also connect my VREPs to the context as well. So this is the context of my dynamic moving shading geometries, and I can pull out the VREPs because the comment is also asking for the shadow of the buildings. I'm putting those in as my context. So if I pull a toggle here, Ladybug false toggle, which would work, but let's put the current versions toggle. I'll be here. And if I run this, let's see what kind of result we are having. So we are having this result. Maybe set object display, and we can have this display as wireframe so that we can see what is happening here. And let me preview this all off. So what we are seeing here is basically the areas that are receiving like sun, right? So for this amount of time. But what we are trying to receive here, what we are trying to have here is having these surfaces, or having the surface in a way that only this portion, right? Only within this portion, so I can scale this down, or maybe put this surface into a location where we are going to have only only this area, so I can rotate this surface and scale it down, really down, put it here, scale it in this direction as well. Okay, or you can come up with a new surface here, right? Why don't we do that? Let's create a new surface. So 1, 2, and another one as a, oops. Okay, it's a bit weird now, but yeah, why don't we have it like this and rotate it a bit, move it a bit, so we're still covering the area that we are covering with the surface that we are having. So we can delete this, set object display mode, and say wireframe for this. Okay, now what we are going to try to have is to increase this areas, or decrease the hours that we are receiving sun, right? So let me set this as one surface and run it. We are going to, you see, it's super, like, it's now extremely okay, maybe we can do the same for this object as well. Set object display mode and shaded, sorry, not shaded, wireframe, so that we can see. Okay, and then what we can do here is to maybe decrease this to 5 to have a bit more, like, you know, shades here. Or you know what, for the sake of this exercise, we can use this mesh as well, right? Like, not like these ones maybe, but the ones that we are having here, like all these surfaces. Yes, but let's stick to what we have earlier on. And if I put this to 2, it's gonna take a bit more time, but I think it will calculate with 2 as well. It's, yeah, you see, it's a bit better now. Maybe what I can do here is to preview this off and just to see what we can do. So what our aim is to now define this, like the hours, the results, is to minimize this, right? So what I can do here is pull out a number, and these are the results. And what I can do instead, I can take this off from this area, can go off here, and I can connect this to here, and I'll be minimizing it. Just to show you the idea, I'll be making this really big, right? I'll be making it really like 5, because I want to show you the optimization results as well. And like, if you want, you can pull out the legend somewhere else, you can change the colors and all those kind of things. But when I make this maximize, go to solver, show all the results, and when I run this, hopefully I would start to see some results. You see, it's changing, but it's obviously a bit slow due to the number of elements that we are having there by each and every iteration or test. So, and this is also considering the amount of building shades that we are having, as it's asked in the comment. And that's pretty much actually it. So I can maybe stop this solver and just show you one more thing related with that. If we make this really large, we probably see results going around a lot fast. So okay, so we are probably stopping the solver now, hopefully. I mean, stop the solver. Because if we increase the number here, like let's say instead of having a grid size of 5, if you have 15, then we'll have faster results. But I'm having trouble to stopping this over. But I think you got the idea. If I can show you this, that would be great, but if I can't, so. Okay, still I'm trying. Let me pause it for a second here. So yes, I could pause it. Now if I make this, I don't know, like 15. Obviously the resolution is going to be too different, but we see different results in a faster manner. So like this, and if I start solver now, you'll see that our points are going to change a bit faster. We'll receive faster results. It's not that fast though. So yeah, it's completely up to you. And let me pause this, or this can go on. In the meantime, I can say, okay, that's pretty much it for this one. I hope you enjoy it, and please let me know if you have any further questions.